Question number 7 of the PhilNITS FE afternoon portion of the exam. We are now in sub-question 1. In this question, we have to answer something about the Heap data structure. And if we look at the blank that we have to answer now, we can see that the blank is letter F, and it's gonna be something related to the heap down function. Okay. Now, if we look at the choices, here we have heap size 0, heap size I, and so on and so forth. Now, when I was answering this, I remember that I ended up doing another set of blanks and skipped this one because I couldn't really figure out why the answer is supposedly letter A, right? Because this part, the 0, I was taking a while to understand what's happening here, but I did get the idea that heap size should be one of the portions of the answer. Heap size, because heap size is supposedly also what we need to give into the heap down function as input, right? And heap size means the number of elements in the data. If it's 10, then there should be 10 elements. And if we look at the heap down function, here we got the word heap size. So heap size and data was given already a while ago. So heap size is definitely one of the parts of the correct answer. Now the problem is the parent. Why is it supposed to be always 0, right? If you look at what's inside the heap down function, we can see that if the parent is multiplied by 2 and then add 1, the other one is parent multiplied by 2 plus 2. If it's always 0, what's the point of having a multiply plus 2 here, right? So if we go back to this part here, we can see that we are supposed to swap the first element with the one that we're currently at, because we can see that we are moving from right to left based on the for loop here. So for example, in this case, 0 would be here, and maybe in this case we are at 15, and we are slowly but gradually going to the left, okay? And we need to swap this one with this one, for example, okay? Now, but that doesn't really quite answer yet why this one is supposedly always 0, except that we have some idea that we are swapping the first element with the one that we are currently at in our incrementing of the index, okay? Now, if we look again at the part here where the description in the text tells us what is also happening, because we look at the code and we see something like this and it's still not quite clear, and there's a description in the text that supposedly explains to us what's happening here much more clearly. And I think that if we are to connect what's happening per number I, in this case 1, 2, 3, 4, this one, the swapping the root node with the rightmost node is supposed to be this part of the code, right? So remember, we have the blank F here, so swapping here we have here, and then the second part in this step is exclude the rightmost node at the bottom of the heap from the heap. And so that's why we are moving downward to, in this case, because the elements, for example, at the start was 10, now we got to go to the 9 because we don't want to include the ones that we are already done, okay? Now, in this case, the third one here is saying that check if the parent node has less value than either of the child node. nodes has. Okay, so what that means is if the parent's value is less than either of the child, then we get the value that has the highest among the children. Okay, and so that's when we go and do the heap down function. And then for the fourth step, we have to apply downward again from the third step. Okay, so we do that recursively, and so that part about doing that recursively, I think, is also key, because if you look at the function, there will be a part here where you got the heap down being called again, right? And it's this one. Okay, just to clarify too, this part where you got another swapping occurring here, this one is pertaining to this part here. Okay, and I think when I was answering this letter, the letter F, for this question, I ended up answering D and E first. Okay, so I know that what we're doing here is pretty much what the description a while ago was telling us too. Okay, look for which child has the higher value than the parent and swap that with the parent. Okay, now in this case, the pertinent part here is the heap down. That means that we are calling heap down again, but in this case, we find that the index is not necessarily going to be 0. It's going to be the index of the child that we swapped with. Okay, and so um, what that means is for letter F at the start, we're gonna give the parent the index 0, but eventually as we move on, the parent did not necessarily have the index to be always 0. Okay, and I think that solves the problem that I was having, because I needed a way to get the parent moving and not be stuck only with the index 0. Okay, so in this case, once we are in the heap down function, we can actually call the heap down function over and over again. And that's why that's called the recursion portion of the code. And with that, we can move the parent. We put in the child index, but again, when it goes to the function, we make it the parent index already. Okay, and so that's why times two this part here would make sense already. It's not always going to be 0, right? And so because of that, the correct answer would really have to be letter A.